All right. Let me double check. So the recorder is recording. We are streaming, and okay. I'm not sure how many of you are interested in the HP Enterprise internship thing. I think to most of you, you probably need another year before you have the experience and also the qualifications that they want to get into that particular internship. Which is good news, bad news. The bad news is, you still won't be able to participate in 2020. But the good news is you have more time to prepare. So by the time you do graduate, you have a better chance to get into that particular internship. So Rodney, the guy who talked about the internship before, he came to my class today, my morning class, and he talked about it again. And the interesting that he told me, or I just realized it today. Do you guys remember he talked about how there were like 80 teams of interns at HP Enterprise, and at the end of the whole thing, they had one hackathon, for the 80 teams of people. Do you guys kind of vaguely remember that? Okay, and ARC won second place, right? You remember that too. As it turned out, ARC was the only 2-year community college within that 80 teams. All of the other teams were from 4-year universities. In other words, okay, the one ARC team was the only team, consisting of students from a 2-year community college or graduating from a 2-year community college, whereas the rest are all from 4-year universities. And ARC still got second place. And they also said, Rodney mentioned today, there's a very strict GPA requirement from the 4-year universities, but the GPA requirement was relaxed for ARC, being the only 2-year community college. So even with that relaxed GPA, the team from ARC is still beating most of the other teams from universities, from 4-year universities. I find that to be quite interesting because one, okay, students from ARC, in that particular year or crop of interns, would not have taken as many classes as the other teams. Okay, it's just the difference between the 2 and the 4 year kind of thing. And the second thing is, with a relaxed GPA, you would think that the other teams would have quote unquote better students or better candidates or better interns, but that turned out not to be the case. So that made me start to think about why it's not consistent in my mind. Something is not doesn't click. Okay, and I think I know why. Okay, there are a few things. Rodney mentioned that all four candidates, or all four not only candidates but interns this time, they all worked at the design hub. So that's one thing that you guys can consider is to figure out what is the design hub and see if that is something that you want to do. Okay, don't go to the design hub and become an intern just because you think you might be able to get an internship, but go find out what it is about and whether it is something that you would like to do. Um, and then the second thing, which also just kind of clicked in my mind, like this morning, was Jeremy Brown, who is the person, who started this program to include 2-year college students into the internship program. He was one of my students. Did I mention that? No? Okay. So he was actually one of my students, but not because I was teaching here. I was teaching at UC Davis at the time. I was teaching the 5th year engineering. How did they call it? It's basically a design class. You have to design, manufacture to make a robot to navigate through a maze. I can show you, videos of that. So let me do that. It's called a micro mouse design, and they're from Davis. I can show you, just a video clip of that. Okay. This is an autonomous robot, which means it is just programmed. It is not remotely controlled in any way. It does not know about the maze configuration, ahead of time. All it knew was where it starts and where it should end up at. So it knows the start location, it knows the destination. It doesn't know how the walls are configured in the maze. So it has to go explore the maze, okay, to find out, how the walls are configured. And as it's doing that, it also wants to get to the destination as quickly as possible, because that's how they score, these mice. It's called a micro mouse, because people also do experiments with actual mice, in a maze and see how they problem solve and figure out the quickest route to a destination. So you might think, this is really easy, okay? Well, it turns out it's not very easy when you're not, building something out of a kit. So these students actually have to do their own research, find the right motors, make their own wheels, make their own tires for the wheel on the wheels, design the circuit board, program the microcontroller unit, okay, build a driver circuit to drive the stepper motors, um, research and find out what type of sensors can be used, how well can they sense the distances. They have to do all the research. They have to research, they have to design, they have to make the prototype, they have to debug, they have to solder the components onto the circuit board, and so on and so forth. It's basically a full product development cycle. Okay, so it just struck me. Jeremy was coming from this class that I taught, maybe 10 years ago. Um, so that means, the HP internship is not about, how good your grade is. Okay? It is one factor. Okay, everything else being the same, having a better grade never hurts. Okay, but it is about, whether you can problem solve, whether you can think independently. Okay, your boss just tells you, I need a robot that can do blah. Okay, specification. Your only question asking back is to ask for a little bit more detail of the specification. Okay, what are the constraints? Can I use internal combustion engine or is it electric only? Okay, what is the size limitation? That sort of thing. Okay, is there a limit on how heavy the robot can be? What kind of processing power do I have access to? What is the cost or the upper limit of the cost of the robot? So those are the specifications that you can go back to your boss and ask about those, but not like, what kind of motor should I use, boss? Go do your research. Okay, I'm gonna stop here. So that's the team, and and the credit was gonna roll out here. So it's really kind of, it just struck me, everything just connected. Okay, micro mouse, Jeremy being in that class. Okay, um, the all four members, of the interns, for 2019, they were all from the design hub. And guess what they do at the design hub? Not exactly micro mouse, but similar. Okay, because at the design hub, yeah, there's no way a student can do this. This is at the expert, basically unlimited level, and it's also from Japan, the land of robots. Yeah, I mean, when you watch this thing doing what we call speed, this is not even a speed run. It is still exploring. It's exploring at a super fast speed. When it did a speed run, you will see later. But we are talking about, not students. These are professional engineers who has no budget limit. The UC Davis one, probably had a cost of, maybe $200. Yeah, these are open class. There's no limitation of cost, like, how much money you can spend on it. You can see how it's going diagonal. This is not even the speed run. Now it's gonna do the speed run. Crazy. And it's real time. There's no acceleration of the frame rate. Yep. So in terms of robotics, I think, the U.S. as a country, has quite a bit to catch up with. Okay, not only in the sense of this, but also in drones. Yeah, less than 5 seconds. So anyway, so the point that I do want to make, regarding HP Enterprise, internship, but not only that, okay, because you're in this class because you are on your way to get some kind of a transfer degree, okay. My guess is, most of you are in computer science or computer engineering. Some maybe in electrical engineering, mechanical engineering, or mathematics. Okay, did I miss anyone? No? Okay. So all of those eventually leads to, guess what? Jobs, right? You guys want to get a job. So the question is, what kind of a job are you planning to get? Okay, and what do you think your boss, okay, your employer is going to look for? What do you think? By the time you are going to get out for a job, what cannot be done by an AI? That would be the first question you ask. What cannot be done by an AI? How about retail jobs? Do you think there'll be any retail jobs left? There'll be some, okay, but if you look at the trend, I think retail is on decline, has been on decline for a while, okay. Um, you look at the Amazon warehouses. Has anyone looked at kind of look into what an Amazon warehouse looks like? Okay. Yep. Okay. Do you work in one? Mm-hmm. 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 I'm going to call that a role reversal. The humans are not telling the computer what to do. It's quite the opposite, right? The warehouse computer, the Amazon cloud computer, is telling the workers what to do. The robots can get some of that done, but what it cannot be done using the robots, the computer will tell the human robots, right? Go to this shelf, go to that drawer, and find this thing and put it into that box. Okay, so as soon as Amazon has enough, can once they can research and do use robotics to do that one last part, guess what? Those people are not going to be hired anymore. There won't be as many people working at an Amazon warehouse anymore. So things are just moving in that direction at a pace that most people do not understand because most people do not get to see that part of an Amazon warehouse. Go ahead. Mm-hmm. So, oh, in San Francisco already. Wow. So shoplifting is mandatory. That's how you shop. You lift. I'm not. I'm just kidding. But they have ways to track what you're picking up into your bag, right? It is fully autonomous. I mean, sure, the first few months, maybe there will be some glitches. Some people are, stealing stuff, from, these stores, but they will figure it out. I mean, eventually they will figure out a technological solution that will catch most people. 100% is never really possible, but they only have to get it to the point where it is profitable. That's it, right? If they can get it to the point where everything is so automated, they don't have to pay more people to work in a shop. So they might lose certain items because of shoplifting, but if that percentage is low enough to justify, well, but the rest, is still okay. We're still making more money than a regular store that hires people. Okay, then there's still a win. Okay, so everything is moving in that direction. When you think about software development, okay, even software development is going in the direction of quote unquote automation. Certain things that was manual, completely manual. Okay, so you work on a program. Okay, you work on version 2 of a program. And version 1 is already deployed. Okay, so in the past, if you want to release version 2.0, There's a huge manual process involved, to push out your version 2.0. They're already pushing in the direction of automated deployment, which means, there's no such thing as a release cycle, that we know of, at this point. It's a continuous process. Okay, the adjustments, fine, small adjustments are being made like all the time to the production software. And that model is made possible because of cloud computing. When you use Google Documents, okay, Google can be making slight, small modifications, adding new features every second, and you hardly know about it, right? Because you don't have to install anything new. Everything is being done in the cloud. All they have to do is to change the software that's already running in the cloud. They don't have to push out anything. There's no app to update. There's nothing to install on your computer. Are you guys understanding what I'm talking about? So even that process can now be semi-automatic or fully automatic. What about testing? Okay, before you release software, you have to test it first. The whole test procedure is being automated, or they are already automated. So every time you make a change in any code, you hit a button, in your editor or in your IDE, what they call an integrated development environment. Once you hit that button, a few things will happen. One, it's going to check into a repository so that it's reversible. People know, what you did to the program, and if it is not working, they know how to get back to the earlier version. Second thing, it will go through automated testing. So the changed code will be integrated into the existing code base, and then the whole thing is going to be tested automatically. If it pass all the tests, then it will be deployed automatically. So even within software development, that entire chain, of a lot of the steps that used to be manual, that used to need people involved in the process, they're eliminating those human factors as well. So those are the things that you have to think about. Okay, would what kind of a work environment are you going to work in, and what kind of qualifications do you need in order to succeed in that kind of environment? So the bottom line is, what cannot be automated? That really is the first question to ask, is what cannot be automated? Go ahead. Oh, I thought you had a question. Okay. I think next year, yeah, go ahead.
What about like network security?
They have bots to automatically look for vulnerabilities now. So those are even they are used by black hats and white hats alike. So you can be hired by HP Enterprise, for instance, to look for a networking environment, to see whether there are security holes, and they have tools to poke in, try to find vulnerabilities. The black hats, obviously have their own toolkit to also automate that process. So that's so who you still need people to make those tools. So you want to be the people making those tools, not the people those tools are replacing or displacing. Yeah. So that's the kind of thing that we have to think about,
Can you
today.
program software to develop the thing that you are developing?
That's kind of the holy grail, in software development. We're getting closer to that goal. Okay, um, it's changing really rapidly. How people write software, how software is developed is changing really rapidly. Um, if you think about cars, okay, what about cars?
What about them?
Hmm?
What about them?
I can't hear you.
Yeah, what about them?
What? Who's going to drive the cars?
AI.
AI, exactly. Now they promise by 2020 we will have automated cars that can drive themselves. Those cars were actually delivered ahead of schedule. Okay, so right now there are other issues involved. Why we do not have self-driving cars yet. I think most of the Teslas are capable of self-driving, but the regulation does not allow that. Okay, at least not in California. They are not allowed to self-drive.
Well, some like they do have some like that are self-driving because like they have ones that like Calix, I believe, has them, where it's like it can take you to a different destination there, and it's
Mm-hmm.
self-driving. Like you don't touch the steering wheel.
Yep.
And then there's like with the Tesla's a little different because it's like you said regulations. Like Europe, they can't do the autopilot and all that because of regulations. But in California, you can somewhat do autopilot. You just have to make sure you're actually 10
So there's a person behind the wheel to
There
take
has to be a
control.
person behind the wheel to make
Mm-hmm.
sure if like, let's say the autopilot fails, because there's an option where it's like there's a safe time to enable autopilot and it won't
Mm-hmm.
let you enable it any other time.
I see.
So like if you try to enable it and it doesn't enable, and you just start like, oh, let me let go, you're gonna hit something obviously because it didn't enable. So it's like there's still a human aspect in driving, but it could be fully automatic if it was like if road conditions were better, it could be fully automatic.
Right. So it depends on the time of the day,
Not time of day, but more like road conditions,
road
and
condition.
also that like country's policy. Like Europe at all, they can't do.
Mm-hmm. They're pushing 18 wheelers, to
Yeah,
be fully automated because that's where the money is.
yeah.
If you can get rid of the human factor in an 18 wheeler, those big rigs, they can, those companies, the transportation companies can save a lot of money if they can take the human factor out of the
They never
equation.
have to stop that either because they can
Yep.
constantly keep going without.
Because by law, they have to stop now. They
Yeah,
even have a logger on the trucks to make sure that the truck drivers get enough sleep, get enough rest.
they have some trucks too that they automatically shut off after a time. The driver. Yeah.
Yep. So without that, limitation, those trucks can, drive like 20, close to 24/7, save for maintenance time and refueling. So things are already moving in that direction, just because there's a lot of money involved, in automation. Um, so I'm not sure how that is going to affect you, within this generation, because it's changes are happening faster and faster. Okay, to use a term in calculus, the second derivative is big. Okay, we're not even looking at the first derivative. We're looking at the second derivative, and I'll even venture out to say that even the third derivative is positive at this point. So things are, they're really increasing, really rapid rate. Okay, so for those of you who are interested in the Design Hub, go check it out yourself. It is TechEd 311. That's the room number. And Randy Schuster is the professor who's kind of managing it. I'm a part of it too, so we can talk about that, maybe after class for those of you who are interested. We just basically work on projects, that has applications. So right now we are doing some projects with the Aerospace Museum. Okay, and you might say, well, the museum, so you're talking about the past. No, we are working on the projects that will, like one team is working on a VR based, simulation, to drive a rover on the moon looking for golf clubs and golf balls. Okay, so that's one team. We have other
Golf
teams to.
balls in moon?
Hmm? Yep.
Golf ball in moon?
Yep. Apparently, one astronaut actually brought along a golf club and left it on the moon. One of the Apollo, astronauts. So you have to read up on Wikipedia to find out who that was. Um, and we work on all kinds of other types of projects related to programming and software stuff too. So that would be a great opportunity, not only for the HP enterprise thing, but also to get you something to put onto your resume for your first job. Because there's always that question: it's chicken and egg. You cannot get a job unless you have some experience, but you cannot get experience unless you have a job, right? So student internship is the one thing that can break that cycle and go like, yep, this is how you can get started. All right.
When the egg came first?
Huh?
Like the egg came first.
The egg can what? The egg can what?
First, before the chicken.
The egg is before the chicken. Then who lays the egg?
Before the chicken. Makes the egg. Then turns into a chicken.
Well, the correct answer is the dinosaur solved that problem because the first chicken egg is actually laid by a dinosaur because dinosaur became chicken.
Yeah, but it
That's
didn't
a
lay
whole
a
different
chicken.
discussion.
But it didn't lay a chicken egg.
It did lay a chicken egg
No, it laid a dino
because
egg.
of the mutation, right?
But it was not a
The
dinosaur.
last dinosaur laid a chicken egg.
Nah, that's not how it works.
after some fiddling by some aliens. All right, so you do have a homework assignment over the break. It's called ByRef. Okay, some of you probably have seen this already. I did not talk about it last Thursday, even though it was actually assigned on Thursday on Canvas. I did not talk about it. So now you do know about it. It is due on the 3rd of December, which is 1 week from today. It's not really difficult. I can click on it and show you what it looks like. So the document you have to download is also called ByRef. It is an ODS, it's a LibreOffice Calc document. And this is what it looks like. Okay. I hope it looks familiar because it should. This is the kind of thing that we talked about on last Thursday. And I even sent you the spreadsheet that I was using on that day. So combining the spreadsheet and also the recording of the lecture, you should be able to apply what you learned on that day to basically go through this program. Is that okay? It's not identical to the stuff that we did on last Thursday, but it should give you a pretty good clue of how to solve this one. So is that okay? Okay. I do know that Thursday is a holiday, Friday is a holiday as well, but this should not take you too long to do. Okay. I think Friday is also a holiday. Yeah, but this class does not have Friday as a day. All right, so that's your homework assignment. Don't forget. And what we'll do today is we're going to look into the interaction between arrays and parameters. So I'm going to scroll to the portion. So this is what we're going to do today is, how do we mix up the concepts of arrays and how do we pass an array as a parameter to a subroutine? Okay, so that's what we're going to do today. And we'll start with an example. Okay, so what we'll do is we will start with an example. I'm going to reuse one of these notepads. So we'll define a subroutine. We'll call it search. And this time we'll do a linear search algorithm. Okay, we can do a binary search algorithm later, but this time we'll start with a linear search. So with a linear search algorithm, you have to pass by value, some value that you want to find. So starting from now, I'm going to integrate the information of type. So we know that k is an integer. This is what it means. Is k is an integer, it is also a parameter that is passed by value. And then we'll pass by reference an array. A is an array of integers. And those are the two parameters. Okay, give me an array, give me the value that I need to find, and we also have to specify a return type. So the return type in this case is a Boolean because I just need to know, is it there or not? Okay, is the value k in the array A or is it not in the array? That's all I need to know. Okay. And to do this, I would need at least one local variable. And the local variable is I, which is an integer. Because I need a local variable to index through the array so I can examine the array elements one by one until one, I find one element of the array that actually has the value, or two, I look through the entire array and that value is not found. And those are the only thing I need. So I would start with the initialization of I. I gets 0 to begin with because I want to start from one end of the array. And we'll say while. There are two conditions for me to stay in the loop. The first condition to stay in the loop is there are still items in the array that I haven't seen yet. Okay, so that is represented by I being less than bar a bar. Because as long as I, being used as an indexing variable is still less than bar a bar, that means I is still a valid index into the array. But in this case, because we are starting with index 0, so that means we have not seen everything in the array yet. Okay, so this is telling us that there are still items in the array to be to be compared to be assessed. The other reason why, the other reason for us to stay in the loop is whatever I'm looking at, which is a bracket I, does not equal to the value that I'm looking for. Because if it does equal to, I should get out of the loop. I have no reason to stay in the loop in that case. So if both of those conditions are true, I stay in the loop. And the only thing I do per iteration in the loop is to increase I by 1. So I move on to the next element and say, okay, can that next element be the value that I'm looking for? When everything is done, which means after we get out of the loop, then we have to specify a return value. In other words, we have to tell the caller of this subroutine, did you find the value k in the array? We have to give it an answer. So I don't need an extra variable for that. Okay, so sometimes we want to use a found variable to remember that, but I don't really need that. How do I get out of the loop? There are two reasons to get out of this loop, right? Because in the conjunction there are two conditions. So that means if I fail at least one of the conditions, I'm going to get out of the loop. What happens if I fail this condition? What if I is not less than bar a bar? What is that telling you?
You already checked everything.
That means I have already checked everything and it wasn't found. Exactly. Because in order for I to be not less than bar a bar, that means I, starting from 0 and only increment by 1 for each iteration, I have explored 0, 1, 2, 3, 4, all the way up to bar a bar minus 1, which is the index of the last element of the array. And yet, I did not get out of the loop because a bracket I does not equal to k was true. That was not true even once. So that means every single element in the array does not equal to k. So in that case, what should I return?
False.
It should return false, assuming what you're returning is indicating whether you found it or not, right? So the value that we are returning is just going to be I is less than bar a bar. Because if I is not less than bar a bar, we should return false. So that means if I is in fact less than bar a bar, we should return true. Is that making any sense? Okay. So we'll end define sub here and define sub. And then we'll define another subroutine called main. And we have a local variable in this case. We'll call it b. Just it's not necessary for this name to be different from the name that we use as a parameter, but I'm going to use a different name just so that it's easier to refer to it. So b is an array of 5 integers. Okay, we'll just use that as an example. And then we'll also give it a we'll initialize this particular array because local variables are not initialized to begin with. So we're going to go through some initialization. B bracket 0 gets a value of 5. B bracket 1 gets a value of 16. B bracket 2 is 2. B bracket 3 is 9. And then B bracket 4 is 0. Okay, it doesn't really matter. I'm just giving the array some random values. So now I can use search as a subroutine. Now search is returning a Boolean value. So that means the invocation of search can go any place where a Boolean value can be used. So that can go into a lot of different places, can it? For instance, it can go into the condition of a conditional statement, right? So I can now say something like this. If invoke search, and then we have to pass the parameters. Do you guys want to search for something that is in the array or something that is not in the array? It doesn't matter one way or the other to me. In the array? And which one do you want to use? 0? Okay, fine. So we use 0 to specify k, which is the number that we are searching for. And then we use b to specify a, because that is representing the array in which we try to find the value of 0. So we say if that is the case, then we print yeah. Else we print, oh no. Okay, that's main. And the only thing we do outside of the definitions of the subroutine is to invoke main. So you will see we're going to do things pretty much in this particular fashion from here on, because that's how C is doing things. Okay, so in a C program, there's no such thing. You won't even see the invoke main. You would just be you'll be writing main as the entry point of the entire program. Okay, so we'll go ahead and trace this code, because that's the main point, is how do we represent something like this when we execute a code. So we'll go ahead. I think I can start with new document. So at the end of today's class, I will make this available, make this document available to you, just like last time. So that way, you can use it for studying purposes. All right, so here's the code, and here's the line number. So please do ask questions along the trace of this algorithm, because I do want to make sure that we understand all the concepts involved in this program. So we add a new sheet, make a new window so we can trace. Okay, leave this one here, bring this one to this side. There we go. Okay. So in the trace, we need comments, because we do have a condition to evaluate. Well, we have actually a few conditions to evaluate. We have line number, and then we have the precondition. The precondition has nothing to say, because we do not have a single global variable in this program. Okay, everything is a local variable or a parameter. So is that okay? Is everybody convinced that B in main is a local variable, and then both A and K are parameters in the subroutine search? You good? Okay. Question? Okay. All right. So the first line that we start to execute from is the only line that is outside of a definition of a subroutine, which is line 25. So we start with line 25. Line 25 is going to invoke main. And the invocation of main means we need a return line number to get to post, because line 25 is the last line of the entire program. But we also have to allocate the space for the local variables in main. So that's going to be array B. So we look up array B. Array B is an array of 5 integers. So now we have to reserve 5 columns, 1 column for each member or each element in the array. So that's what it's going to look like. And then we'll shrink the columns a little bit, just so that it's easier to keep track of everything. I know you guys cannot see this part, so let me put this in here. So highlight all the columns, and then double click on the bar in between the columns, and it will shrink it to as small as possible. And all of these are question marks, because at the beginning, these are all local variables, and they all start with some value that we do not know. So that's the entry point. Okay, this is how we set up the columns before we get into the first line of main, which is on line 14. So line 14 doesn't do anything too interesting. B bracket 0 gets 5. On line 15, B bracket 1 gets 16. On line 16, B bracket 2 got 2. On line 17, B bracket 3 got 9. And then on line 18, B bracket 4 get a 0. Okay, so far, nothing too exciting. But it does illustrate that you can have an array as a local variable, which is, in this case, that's B. Is that okay? We are already mixing up the concepts, okay? We are already mixing up the concept of an array and also a local variable in this case. So is that okay? Is everybody feeling comfortable with, B is a big variable. It has got 5 components to it. That's basically one way to look at B. Is that okay? All right. Okay. Assuming this is okay, then we get to line 19. Okay. Line 19 is a conditional statement. It's the beginning of a conditional statement right here. But in order to decide whether I should go for the then branch, which is on line 20, or go to the else branch, which is on line 22 that you cannot see, we have to first figure out what is the value of the invocation. What value is it going to return? Is it going to return true or is it going to return false? We need to know that. So that's why we have to invoke search first. Then we can come back and make that decision later. So that means now, in terms of the trace, we have to set up the columns for an invocation of a subroutine that does return a value. So on line 19, when we get to line 19, now we have to set up return info because it is returning a value. And when the subroutine does return, we want to get back onto line 19. What is left on line 19 to do is to make a decision. The invocation itself is replaced by a single question mark because that question mark is it's basically a placeholder for the return value. It's basically saying when this invocation of search is done, the question mark should become a value, either true or false. Then we can actually make a decision to go to either the then branch or the else branch. So are we good so far with how we set up the return info cell? That part has not changed from before. The way we pass the parameters is a little bit interesting in one case and not so interesting in the other one. K is passed by value, which means we are just asking the caller, which is main, and say, okay, what do you want to specify for parameter K? We look up line 19, and it clearly states we want 0 to be used to specify K. Okay? So K starts with a value of 0. Not a problem, because it is passed by value. But when we look at the other one, which is parameter A, we use local variable B of main to specify parameter A of search. Okay? And it's linked by a double-sided arrow. So now the biggest question is, do we have one cell for each cell of the array, or do we have just one cell to refer to the whole bunch of cells that B is? That's kind of the only question you have, because it is passed by reference. It is not passed by value. In C and C++, you cannot pass an array by value. That is simply not allowed in the programming language. You can only pass an array by reference. So the way I'm going to represent it here is we only take up one cell. A is basically an alias, or it refers to columns, in this case, D to H. Okay? This is how I'm going to use, this is what I'm going to use to represent, how you pass an array by reference. So that's how we do it. So once we set up all the columns, we can now continue execution in the subroutine. So when you look at the subroutine, we also have a local variable I. Okay, so we better allocate for local variable I here. And because I is a local variable, its value is unknown at the entry point of the subroutine. So are we still doing okay so far with this trace? Yes? Okay, very good. Let me shrink B a little bit. Later on it can get a little bit big, but for now it can shrink.
Excuse me?
Yep.
We can also do zoom out a little bit.
Yeah, we can zoom out a little bit so you can see more like that. Okay, can we see everything? Yep, okay, good. All right, so now we get into the subroutine that we are calling, which is search. And in search, we are going to start with line 6. Line 6 says, local variable I should become 0. Okay, so that becomes 0. Line 7 says, we are at the beginning of a loop. And it's asking, is I less than bar A bar? Okay, so how do we answer this question? Is I less than bar A bar? So the first thing we do is, it is true, because we look up A. A says, don't look at me. I'm only referring to columns D and H. D to H. So when you look up column D to column H, Those 5 columns together is representing an array that has 5 elements. So the question of bar A bar is really asking, how many elements are there in the array that is occupying from column D to column H? And the answer is 5. Is 0 less than 5? Yes. Okay. So the answer is true. And then we go to line 8. Oh, wait, I'm not done yet. Okay, so the left condition is true in a conjunction because you can, okay, I need to move things around just a little bit because on line 7, the condition is a conjunction, and then the other side of the conjunction is asking, how about, so let me get rid of that first. What about A bracket I, compared to K? What are we doing here? What is A bracket I? Let's try to figure this out. Let's figure out what A is first. A is referring to columns D to H. Columns D to H is an array that has 5 elements. Okay, so each element is, the elements are indexed 0, 1, 2, 3, 4. So when we add a square bracket after A, we're saying whatever array A is referring to, I need to look at the one that has an index of I. Okay, let's look up I. I is 0. So we are referring to element 0 of the array that A is referring to. That turns out to be D to H, and the first element is the one that is in column D. It has a value of 5. What are we looking for? We're looking for 0. 0 does not equal to 5 is? No. It's the other true. It's the other false. It is true, okay? So we have true, yes, I is less than bar, and it is also true that A bracket I does not equal to K. True and true is true, okay? So now we know the condition of the loop is true. So what do? Well, I guess we don't have a choice. We get into the body of the loop. I'm going to leave this one kind of truncated for now because otherwise I don't have enough room to show everything. So now we have to move on to line 8. Line 8 doesn't do anything too fancy. All it does is to add 1 to I. I is now 1. Then we go back to line 7 again. We ask the question. What do you think? I is now 1. Is I less than 5? Yes. We look at element 1 of the array. It has a value of 16. We are looking for 0. 16 does not equal to 0 is true. So once again, we have true, and the condition itself is true. So we says, basically repeat the condition, okay? Press the enter key. We go back to line 8. I is incremented again from 1 to 2 this time. Go back to line 7. Same deal, because even though I is now 2, 2 is still less than 5. So that's the first true on the left-hand side. And then we look at A bracket 2. A bracket 2 is referring to element 2 of the array that A is referring to. And that turns out to be column F, which has a value of 2. 0 does not equal to 2 is true. So now, once again, we have true and true. So we have not, we cannot get out of the loop yet. We go to line 8. I is incremented from 2 to 3. Go back to line 7. Okay, guess what? Nothing important or nothing fun is happening yet. Because, even though 3 is less than bar A bar, which is less than 5, and then A bracket 3 has a value of 9. 9 does not equal to 0 is true. So we have true and true again. We go to line 8. I gets incremented to 4. So now let's check out what's going to happen. Okay. I is less than bar A bar is true. Okay. But A bracket I does not equal to K is false. So that means the whole thing is false. Okay. So when it is false, we get out of the loop. So we end up on line 10. Line 10 is a return statement, but there's no invocation in the return statement. So that means we can just evaluate whatever expression is to the right-hand side of the return and just say, well, we'll go find the question mark and replace the question mark with that value. So we look at the return statement. It's saying whatever this expression is the return value. I is 4 at this point, and bar A bar is 5 at this is 5. 4 is less than 5 is true. So the expression of that's next to the return keyword is true. So what does that mean? That means we're returning a value. So now please do look up the rightmost in use column that is labeled return info, this guy, copy and paste it, and change the question mark itself to true. That's all we do. Okay? We are not continuing on line 20. Okay? Not right now. We'll do it later. But right now, all we do is to replace the question mark with t, or the return value. That's all we're going to do. And then we get to line 10, in line 11. On line 11, we are going to deallocate a bunch of columns, and then we have to figure out where to go back to. So the first thing we do is to figure out where we're going back to, which is on line 19, and we'll copy and paste the entire cell. And then the second thing we do is we have to deallocate all the columns that we have allocated for this invocation of search. And that goes from column I to column L. Okay. Yep. Apparently when this happens, it freezes up the keyboard too, so I can't really type anything. There we go. So Control C, Control V. Oh, I didn't do the Control C properly. Here we go. Control C, Control V. Yes, there we go. And then strike out everything. There we go. So now we continue execution on line 19. What should we say in the comments on this, in this case? Well, we just say true is true. The first true refers to the value of the expression. The second true refers to what it evaluates to. Okay? So we say true is true. So we go to the then statement. The then statement is on line 20. When we print something, all we do is to just kind of echo what we are printing in the line of the comments. Okay? So we just say, yeah. There we go. We get to the end of the conditional statement. There's nothing after the end of the conditional statement, so we end up on line 24 right away. So we look up the rightmost in use column that is labeled return line number this time, and that says post. So now we know, okay, we're supposed to go to post, but don't forget to deallocate all the columns. So this is where it is kind of handy to do it this way, to kind of indicate that B spans across 5 columns. If you just refer to B, it is from column D to column H. But if you want to access individual elements in the array, you can say B bracket 0, which only refers to column D. So we take these two, okay, copy it, and paste it over here, and then just use a text strike through, and then we continue execution at post, which means we are done. So do we have any questions about this trace? You can refer to a row number if you have any questions about any of the steps of the trace. Questions? No questions? That went over easy. Yep, go ahead.
So I'm mixing the duty of the return, line 10, and also duty of line 11, and define some. So what we do when we get to the return? Do we return a value or do we return
When you mean line 10 or line 11?
line 10?
When you get to the okay, that's a very good question. Okay, so I'll in pseudocode in this class. Okay, when you execute a return statement, all it does is to copy and paste the return info cell, and then change the question mark to the value that you're returning. But it doesn't change the flow of the program. In other words, you move on to whatever is next to it. Is that okay? So we still move on to line 11 that actually does the returning from the subroutine to the caller. So there are 2 returns here. One is returning the value, specifying the return value. The second one is to continue execution to the caller. So in pseudocode in this class, we separate those two as two different steps. In C and C++, they're combined. So when you get to the return statement on line 11, it's going to do both the job of returning a value and also continuing execution at the caller. Is that why you're asking the question? Because you have some exposure to C and C++ programming?
No, I did a little bit of Java.
Yeah, same thing. Java has exactly the same meanings, the same semantics. So in this class, I break it up into two steps, but in those programming languages, as soon as you get a return, it also gets to the end of the subroutine automatically. All right. Any other questions? No other questions. Okay, let me ask this instead. Do you need a little bit of time to think before we move on to another topic? No? Okay. So is the consensus no? Okay, all right. So let me make sure I save this file because this is important. So save, and we'll save it to a saved document, to a location that is relatively safe. So where should I save it to? Document is fine. We'll call this 2019 1126 underscore array. Okay, that should be pretty safe. Okay, what about binary search? Can we do binary search as a subroutine? Sure, just copy and paste the binary search thing into the subroutine search, and everything is good. So that doesn't seem very exciting. So what we'll do is we're going to write a recursive version of the binary search algorithm. Is that okay? So I'm writing the code, so we only, in this class, the class only has to be able to follow the logic of the code, but not necessarily coming up with the code itself. So let's go ahead and talk about binary search. Define sub binary search. We'll call it B search. We still need to pass by value the thing that we're looking for. So we still have by val k, which is the integer. We still have to pass the array along. Okay, so we still have the. This is going to be kind of redundant. I'm going to do all of these and then do the indentation all at once. So we still have to pass by reference the array, okay, which is an array of integers. Okay, we still have to have the local variables. Okay, so if you remember from the discussion of binary search, there are three variables that we need to define. There are three local variables in this case. One is m, which is the index of the element that we are looking at. One is b, which is the first index of the array that defines the range of elements that still has the value. One is e, which is the index of the last element of the array that may still contain the value that we are searching for. So all of these are integers and they're all local variables. So instead of using one line for each one, I just combine all three onto the same line, which is typical of what you can also do in a programming language. So as some of you probably still remember, okay, we have to initialize b. Actually, I take it back. So assuming this is, how should I put it? Sorry?
I just said b is equal to 0.
Yeah, there's the initialization, but I'm going to restructure the program a little bit. I'm going to say all of these b and e are passed as parameters, but the only local variable is m in this case. M is still a local variable that is an integer. Okay, so this is the setup to make it possible to perform binary search recursively. Okay, so we'll see how this is actually going to be used. So you are given, what are you given with for each invocation? You're given with all of these parameters. You are told what value we are looking for, that's k. You're told what is where to find the array in which you want to find a value. That's the job of a as a parameter. You're even told B and E. In other words, you are already told, don't look, in the entire array. I'm already telling you, okay, the value k can only be found between this index B and this index E. I'm already predefining a particular range for you to look into. Okay, so even that is given to you. M is a local variable, so we still have to figure out what M is. So the rest of the code goes like this. Okay, M is, if we still calculate the M using the same method as what we did before. So this is going to be the floor of B plus E, the whole thing divided by 2. Okay, it's kind of quote unquote the midpoint between the B and the E. And we still have a comparison. Okay, we still have to compare K against A bracket M and see if it's less than. If it is, we will do one thing. If it is not, then we ask another question. Then we ask whether K is greater than A bracket M, because if that is the case, we're going to do one thing. And if not, we'll do some more thing. And if, and define sub. Okay. So I think some of you are convinced that indentation may be helpful here. So we'll go ahead and do some indentations. And that's one block. This whole thing is another block. And now we need to go back and backfill these things. So binary search only works when an array is sorted. But there are two ways to sort an array. You can sort it in increasing order, or you can sort it in decreasing order. Now, I think in this class we have consistently used the order of increasing or non-decreasing, so we'll keep that order. So if the array is sorted in a non-decreasing way, what you're looking for is less than the element you're looking for. What should I do? Which half can I toss away? The first half or the second half? Okay. The second half. The second half, because if k is less than A bracket M, then k is also less than A bracket M plus 1, which is also less than A bracket M plus 2, and so on. Is that making any sense? So we are moving E forward. We're moving E to be closer to B, but we are not moving B when the condition k is less than A bracket M is true. So what I'll do is I'm not going to finish this yet. Okay, I'm just going to use the comment here and say move E closer to B. Okay, that's all I'm going to say for now. What about here? If I can confirm that k is greater than A bracket M, that means k is also greater than A bracket M minus 1, which is also greater than A bracket M minus 2, and so on, all the way back to A bracket 0. So that means, oh, we can move B. We can move B to be closer to E in the case of k is greater than A bracket M. Is that making any sense?
Can you say close to the M because it's the midpoint?
Move B closer to E.
Close to M, the middle.
Yes, M is where M minus 1 or M plus 1 is where we want to move it, but I'm just looking at B and E and ask which one am I moving. So that's for now, okay? Okay, we'll handle this one. This is the easy one. We know exactly what to do. Because how can we possibly get here? We only get here if we can first get here, right? But we can only get here if k is greater than or equal to A bracket M, right? So once we are here, we can only get here if k is less than or equal to A bracket M. So that means by the time we get here, we know that k is less than or equal to A bracket M, but it's also greater than or equal to A bracket M. What does that mean? It means they are the same, right? K and A bracket M, they must be the same by the time we get to the cell that is highlighted right now. Does that make sense to you? Yes? Okay? Because if it does not make sense to you, I can explain it one more time in a slightly different way. So are we good so far? Yes? Okay, all right. Um, then what should I do? Knowing that by the time I get to line 13, K and A bracket M are the same. What should I do? Okay, what is the purpose of the entire subroutine? I give you a value, I give you an array, I tell you where to start, where to end, but what do I really want as a result? Is it there, right? I just want you to tell me, is K in that portion of the array? What should I do here? True or false? We got the answer. Okay, so how do we report an answer to someone who called it as a subroutine? Return. Very good. Okay. We just return true. Very good. That's all we do. Return true, and we are done. Cool. What about the other two cases? What are we going to do over here?
We can add from here.
Hmm?
We can minus m b m
Okay.
minus 1.
Okay, very good. Okay, so we can say, okay, so let's try to put all the parts into a box, and then we'll rearrange things in the box a little bit. Okay, so there's a little bit of something like E needs to be updated, and the way we want to update E is it should become m minus 1, right? And in the other version of binary search, we will be going for another iteration of the loop, right? Do this whole thing again, right? So do it again. Okay, that sounds pretty good. And we'll figure out how to better express that. But for now, we'll just go with this. Okay, so this one is going to be, we're going to move B to where m plus 1 is, and then do it again. Okay, this is where recursion is going to be cool, because do we have the logic to handle the case where I know where E is supposed to be, B is not going to move, the is the same, the value we are searching is still the same. Do we have the logic to handle that? And we are searching for a particular value within a smaller portion of the array this time. Do we know how to do this? Yeah. The subroutine that we're in right now. So what do we do? Exactly. We do recursive invoke. Okay. So don't write this code yet, because there are still a few adjustments that I need to make. But we are building the program, the algorithm step by step. So we say, well, as far as I know, I have not found the value that you're looking for yet. But you know what? I know someone who can do it. I know there's a subroutine called bsearch, and we just have to specify the parameters. Whatever you tell me to search is whatever I'm going to tell bsearch to find. Whatever you have as the array passed to me, I'm going to pass it along to bsearch. Whatever B or the first index that can have the element that contains the value is also going to be passed along the way it is. However, the end of the portion of the array that may contain the value is no longer E. It is now m minus 1. So I'm going to use m minus 1 to represent, to specify E in the recursive call of bsearch. That is how the recursive version of binary search can be implemented. Okay, let me indent this one more time, because that's out of indentation right now. There we go. Does that make sense? Okay, let's just pause here a little bit and ask, does it make sense? So what it is really saying is, I was given a stack of cards, okay? And I was also told, this is the value that you need to find. And I was also told, within the entire stack of cards, focus on from here to here. That's all I was told. Okay? Then what do? I look into the range that I was told to find K. I pull out the card right in the middle within that range. I look at that card. I look at the value that I was told to find and go like, nah, not the same. But not only they're not the same, the value I'm supposed to find versus the card that I pull out of the stack is related this way. Okay, the value I'm supposed to find is smaller than the card that I pull out of the stack. Is that okay? Then what do? Well, I go like, I'm lazy. I have done my job already. It is your turn now. Okay, I'm just randomly picking you. So it is your turn now. Okay, so what do? I say, this is the value you're supposed to find, which is the same as the value that I was told to find. Okay, I give you the entire stack of cards. I tell you where to find the stack of cards. Okay, this is how you find the entire stack of cards. I look at where I can start looking. Okay, and I say this is also where you can start looking. Okay, the only change is I was told that I can end with index E, but I know better now. Okay, because of the one comparison that I did, I can now say you don't have to end over there. I can already tell you that part of the array cannot possibly have the array the value of k. You can end earlier now. This is the earlier point where you can end. And then I just walk away and I say, whatever your answer is, I'm going to use that answer to report back to whoever asked me to begin with. Is that okay? That is recursion. So what are you going to do? You're going to do exactly what I did. Okay? You just go through this whole logic here, and somebody else may be needed in order to answer the question. Is that okay? So that means the other one, what I mean by the other one is the other comment here is going to be something that is very similar. You say return, okay, invoke, okay, I forgot about the word invoke earlier. I'll add it later. Invoke B search. It's raining. Okay, K is still K, A is still A. But this time B is changed, okay, because of the comparison. We know, don't start with B because we already know, you can start later, okay? So M plus 1 becomes the starting point of the recursion here, but E is still E because, it does not impact E because of the comparison. So that is recursion. Okay? But this algorithm is going to have a problem because what happens when the element or the value k cannot be found anywhere within the array? Now, if you remember the original algorithm, that is indicated by a condition of b is greater than e, right? But nowhere in this logic here, we're checking for that. So that means we're missing something in this algorithm. What we're missing, we need to add a little bit here. So we have to insert 2 rows on top of this, actually 3 rows. So we'll insert 3 rows in front of this, and then we'll also insert one row, just 1 row after this. 1 row after this, okay, and I'll specify what goes in and what goes into these rows. The first thing we need to do is to indent again, okay? All of this stuff here is going to be indented because they'll all be nested within another conditional statement. The other conditional statement, which is on the outermost portion, the first question we're going to ask is, are you trying to trick me? Are you going to trick me? Are you trying to tell me, the index of the first element is already greater than the index of the last element? Because if that is the case, I'm not going to do a single thing. I'm just going to say, there's no way I can find a value, because the region of the array that you're defining has no elements in it. So if that is the case, I can return false right away. I don't even have to do a single thing. All I have to do is to say, nah, nope. If B is not greater than E, then I do everything else that we specified earlier. We also need one more and if, because we're adding one more level of conditional statement here. And that is the whole thing. This is the entire algorithm, binary search algorithm, but implemented as a recursive subroutine. Are we still doing okay so far, or do you need a moment to think about this before you can think of a question to ask? No?
So we don't specify B and E.
So that is a very good question. So in main, how are we going to invoke this algorithm? So that's a good question. But before we answer that question, do we have any questions about the code as it is now? No questions? We got 2 minutes or 3, close to 3 minutes. We can finish the code at least. So we'll define main, okay. We have local variable b, which is an array of 5 integers. Okay, we'll do some initialization. B bracket 0 is 0. B bracket 1 is 9. B bracket 2 is... This time it has to be in an increasing order, so I have to be careful not to break the ordering. Okay, so the invocation this time is going to look like this. Okay, we have to say invoke b search. Okay, you have to tell me what value you're looking for. Okay, let's say 16. Okay, so we specify 16 as k, which is the value that you want me to look for. B is the array in which I'm doing the search. But this time you also have to tell me initially that the 0 is where we can start, and then bar b bar minus 1 is where we end in the first invocation. So the way you call b search is now different from the way you call search, because when you call search, you don't have to say start from here, you end here. You're implying that we have to look at the entire array. But in this case, we do have to start and say the first one, the first person who gets the problem to solve, has to start from the very beginning of the entire stack of cards and end with the entire stack, the actual end of the entire stack of cards. Because at that point, there was not a single comparison to throw away anything in the stack. Is that okay? Yes? Okay. So the rest of the program is going to be about the same as the other one. You know, we print yeah or found, okay. Else print not found, and if, and define sub, that's main, and then you invoke main. So the indentation is not fixed up, you know, but that's basically the code that we can use in order to utilize a recursive version of binary search and using the concept of passing an array along as a parameter. So is that okay? Yep.
The algorithm only works for sorted array.
Yes, binary search as a whole, okay, only works on arrays that are sorted, whereas the other one will work in any array, sorted or not. All right, so happy Thanksgiving. I'll see you guys next Tuesday, but don't forget about the homework that is due on next Thursday. I mean, next Tuesday, sorry. I'll see you on next Tuesday, not next Thursday.
Happy Thanksgiving.
Yep, you too.
Excuse me, sir, I have a question.
Yeah.
So